Welcome. My name is Sonia Cuff. I run a team inside developer relations for Microsoft. Now, developer relations is an interesting part of the company because we don't report through to marketing. We don't report to sales in our field where your account managers live. We actually report through to engineering up through Scott Guthrie. What that means is that I am uniquely qualified in probably this entire conference to be one of the only person that is happy to have 45 minutes of your time to talk about how to spend less money with Microsoft. Just checking, are title slides up on screen? No, can we bring up my deck, please? Yes. My apologies. That's my job. There you go. Fantastic. Okay, so let's get started. I'm going to break this talk down and give you some advice, starting with things that you need to consider for AI workloads, how we can do some cost analysis and optimization of your workloads and your rates, and how to manage your costs with FinOps. Let's start at the very beginning. It's a very good place to start. What I want you to think about when you're looking at AI applications inside your organization is the fact that the AI service itself is one tiny component of that application architecture. And as usual, for any application that you are putting into your organization, your business requirements should drive your architecture decisions. So, what performance does it need? How much load is it going to have on it? How responsive does it need to be? What level of resiliency does it need to have built in? What are the plans for business continuity and disaster recovery if this application is unavailable? All of that foundational knowledge that you apply to any workload, you need to apply to your AI applications. In addition to that, AI services come with a few quirks of their own. So you've got to think about things like model processing capacity, per call latency that fits into that responsiveness. And when you're looking at things like BCDR, start to learn how you can architect that for AI. So here's a good tip. Azure AI Open resources, you can deploy into different regions, but they won't automatically fail over if one region is down. So do you need to build some resiliency into your application so that it will check and poll and point to a different LLM endpoint, or do you need to add on a different solution at the networking layer to do those redirects? So I mentioned that the AI services are just one little part of your application. Let's take a look at what it means when someone says that they're going to deploy AI into their organization. And by AI, I'm talking about custom-built applications that have an AI component in them, not an AI as a service like our copilots. Here's one example, this Azure OpenAI service. We've got some containers in there. We're using identity with Entra ID, and you can see that the AI service, Azure OpenAI in this case, is just one little box in that entire application architecture. So when someone comes and says to you, how much does AI cost? The answer is, it depends. Right? It depends on what else you need to put around this total application. So remember to think about the entire application architecture first. Here's a different example. This is an e-commerce store built on .NET. So it's actually using PostgreSQL, event bus, it's using webhooks. So now you've got some serverless functions in there and some storage types that you need to take into account as well. Again, AI is just a very small part of the conversation. And finally, we have an application architecture that is taking in and processing audio files. It's doing a speech-to-text translation. So now we've introduced Azure Functions, and we've got some storage and some processing of the files there again. So three very different types of what AI looks like in our organization. But fundamentally, coming back to those business requirements, driving your technical decisions, your infrastructure cost considerations are where you need to start to make sure that you're also looking at those. So your AKA scaling costs, whether you're using serverless, deploying to availability zones or other regions, what storage you're choosing. Are you load balancing? How is your networking configured? What security products are you using? Are you sending monitoring data to log analytics? And do you need to? And how are you backing this stuff up, especially including the data? So all of these different decisions are going to add into the total of what AI is going to cost me in my environment. The second thing that we need to look at is how is the AI service itself structured in terms of cost meters. So what influences that AI service that will make it generate more cost? This is an example that I've pulled of some of the Azure OpenAI services where if we have a look at the GTP5 global model, you're starting at $1.25 US per 1 million input tokens. And we'll have a conversation about tokens in a minute. But then you've got an output cost of $10 per 1 million processed tokens compared to GPT-5 Nano Global, which is a much smaller model, our nano models, where you're looking at 5 cents for a million input and 40 cents for a million output tokens. There's a big difference just between those two. So model selection matters. And when somebody says how much does AI cost, it's not just how much does the application cost, it's how much is the service and how much is the particular model going to cost. Are we making the right decisions on that? Fine-tuning models have an hourly rate for training and hosting. So as soon as those fine-tuning services are provisioned, you're paying for the cost on an hourly basis. If you want to stop paying that hourly cost, you have to delete that fine-tuning resource. Okay, so again, you might not think of an AI service having an hourly rate. Fine-tuning does because it spins up a VM to handle the fine-tuning instance. And then you've got things like image and video models that are based on resolution, how much audio they're handling or what the resolution of the output of the images that you're generating. So get deep into the particular AI services that you need for that application and understand how it's structured. Azure AI Search has a slightly different pricing model. So instead of being on per million tokens, it's broken up into these SKUs, these stock keeping units. So you need to make a decision around how much storage, maximum indices, scale out limits, etc. that you need, and that's going to give you a price per SKU that comes with all those different flavors. This might be a little bit more familiar if you're used to sizing virtual machines, where you're picking a VM SKU that has all of these different capabilities in that t-shirt size. So this is how Azure AI Search is priced. But Azure AI Search also has the ability for you to import a sample of data and it to give you an estimate in terms of how much storage you're going to need, and then you can figure out which of those SKUs is going to suit you best and what the cost is going to be. So that one's got a little bit of an estimator in terms of taking your raw data and giving you an example of what it actually works out to as far as when it indexes the things. Now, I did promise you that I would come back to tokens. Tokens are the billing currency of large language models. Large language models don't recognize text. They take a series of words and characters and they split it up into tokens. And in those tokens, it recognizes patterns. So let me just cue this up and I'll give you a quick example. Unfortunately, OpenAI have actually taken down the link to this tool from their website. But I'm going to use it as an example anyway because I think it gives us a very nice visual. So they used to have this tool called the tokenizer where you could actually go and paste in a piece of text. And what I've done here is I'm pretending that I run a shop that sells outdoor equipment and hiking gear. And what I've done is I actually got Copilot to generate me a list of standard questions that a customer might ask if they're interacting with my website. I want to add an AI chatbot onto this site. So this is just a tiny fraction of what a standard conversation might be, and when I paste that into Tokenizer, it tells me that that actually breaks down into 81 tokens. That might be a good estimate to start with when I'm looking at pricing, and then I can kind of do the math to extrapolate. If this is roughly the average conversation I think somebody might have on my website, I currently have X amount of hundreds of people that interact with my website on a daily or a monthly basis. I'm going to guess that 25% of those might use my chatbot function, or maybe even 75% if I want to be optimistic. So therefore, this amount of tokens times by my pricing multiplied by the number of people that I think might be using it is going to give me a better suggestion in terms of what my costs might be than just trying to plug numbers out of the air. Not necessarily going to be super accurate because customer behavior might be different on your website, but then you get into cost analysis and monitoring to see whether or not the reality actually matches what you're expecting and whether you need to adjust anything. One interesting thing to see about these tokens, in this example where it was running it through the GPT-4 models, it broke it down into 81 tokens and 373 characters. But back in the day when we had GPT-3, that would have broken it down to 92 tokens. So that shows us that the evolution of the models means that they are becoming more efficient in tokenizing the input and the output data. Again, it's not just about which model is going to cost me more, but the newer GPT models are a lot more efficient in breaking down tokens. So your actual token count that's going in and out of those services may be different depending on which model you're using, and generally the newer models will be more efficient. Okay, the next thing I want to show you is the Azure Pricing Calculator. Hands up if you used the Azure Pricing Calculator before. Yeah, it's pretty much the website 101 as far as cost goes. So in our Azure Pricing Calculator, no thanks, I'm good, we can go and type in things like Azure OpenAI, and it will add that as a service. Now, in the service, that's where it's going to ask us to start customizing things. So, like virtual machines, which region is it running in? Because different regions have different costs. Different regions have different costs if you're wondering, because there is a different cost of expenses to run those data centers in different locations. Then we've got which kind of model type are we using, which particular model are we using on demand pricing or one of our savings plans and our commitment discounts. And then it's going to ask you for the input and the output tokens, and some models also have cached input tokens where they will tokenize the text, hold those tokens in cache, and then when they need to go back and reference that text, like in the context of a conversation, instead of re-tokenizing another set of input, they'll go back to the cache tokens, so they don't do the tokenization process twice. That's what your cached input is. Not all models support it. But you can see here that if you were unfamiliar with pricing AI services and you went and you added this to your estimate and it came up and said, how many tokens are you running? That's a little bit hard to figure out unless you saw the first part of my talk where I explained about tokens. Now I did mention that that OpenAI don't link to that tokenizer page from their website anymore. The slide deck does show that there are two options available for doing tokenization as well. There is TikToken and JToken. So TikToken is Python-based and JToken is Java-based. I actually had to play with that as an IT pro who doesn't do coding software. I was so proud I installed Python on my machine, and I actually ran the Python tokenizer and got it to work with the help of some documentation. So there are a couple of sort of command line tools for doing that, but you do need to have an estimate for those tokens. And then also on the pricing calculator, if we go over to our estimate templates, if you're familiar with this, it used to be something like example scenarios is what it was called. It's just had a fairly recent update. We've got some that are featured, and we've got some AI suggestions here where we can actually view a pre-built architecture and we can add that to the estimate. So that will add all of those different products to our, the Wi-Fi is not fast, to our estimate. It'll add all those different products, and then we can go and, yeah, you get the idea. It'll add it to the estimate, and then we can go and change the specifics in each of those servers in those suggested applications. I love links. They're in the deck if you want to download it from the session resources page, or if you're super keen, you can take a photo of it now. But here is some more information on the pricing calculator, how the Azure OpenAI pricing is done. And we've also got some documentation on plan to manage the costs for those services. And again, more information. Each of the products have actually fairly comprehensive pricing pages to go and learn more. Okay. So we've done the estimation thing, we've put this into production. Let's have a look at how we can analyze the costs of these workloads. Great stuff. So inside the Azure portal, no, that's my Copilot demo. Excuse me, just a second. Here we go. Okay, so inside the cost management and billing blade in Microsoft Azure, we have an entire cost analysis section, and there are a few kind of reports in here. If we go to the services pane, shows all the different types of services that are grouped inside our Azure subscription, and the one that we are going to look for is Azure Cognitive Services. So Cognitive Services is where our AI services and our Azure OpenAI rolls up to under the AI and machine learning service category. So we can flick through there and we can get a fairly comprehensive list broken down into the different models and the token types of what the cost is in that period for the input and the output tokens on the particular models for those services. Another way to look at it, we can go into the accumulated costs graph. Now, the accumulated costs graph is interesting because it looks fairly simple and standard when you first look at it, but the power in this tool is in the filtering. So if you can play around with the filters in here, what we're going to do is just expand the range of cost data that we're looking at. And then we can go and add any of the filters in here. So for our AI services, I'm going to go and filter to service name and then choose cognitive services in here. And that will give us the cost over time. I'm going to group it by resource, and that'll show me the different models that I've got deployed, the different AI resources that I've got deployed over time. You can click on any one of those resources and filter by meta type if you want to get down to individual models. As well as that, the resource pages themselves inside Azure also have some data. So this Azure AI service, if I go under the monitoring section, I can go and take a look at some of the metrics. So again, remembering that the cost is generated by the usage, I can actually see the number of Azure OpenAI requests to the service, or I can come down and filter on things like the number of processed prompt tokens, so our input tokens, and I can see that usage over time where I've got peaks and troughs. If I've got a spike in my costs, I can come back to here and find out when did the usage spike. And a lot of this analysis is actually putting those two data points together, the cost numbers and the usage metrics, which drive those costs. The Azure OpenAI service on the overview pane has some graphs down the bottom as well. You can look at HTTP requests, but you can also look at your token-based usage under here. So again, this will give you some information over time so that you can see the peaks and troughs in that usage. Next I'm going to show you is Copilot and investigating costs. This is a fairly simple demo, but of course you can go and use Copilot to interrogate your costs and get some more information at Copilot in Azure. My biggest tip for using Copilot in Azure is you can drag that window over to the left. So if you hate working in a box that's this small, you can actually drag it and give you a little bit more screen real estate. And I hope that was worth the price of the conference ticket, because that is my biggest tip that nobody knows about. So I can go and ask it about the cost in my environment. Did my costs spike in the last 3 months? And this capability is continuing to improve as we work on the capabilities of Copilot in Azure. I'm going to ask it for a detailed breakdown of the Azure cognitive search costs. So it's going to go and feed through that data and give me a list of information about what is making up the majority of that cost. And then I can also ask it, I'm asking it here, if it can give me some recommendations on how to lower those costs. So it's going to give me some good advice and information on that as well. Next thing I want to talk about is workload optimization. So it's all very good knowing how to estimate and knowing how to analyze the costs, but what are we doing within the workloads themselves to make them as cost efficient as possible? Now, Microsoft Foundry announced some capabilities in Control Plane during this little event, and there are two in particular, model routing and token routing, that can actually help us with our costs. So this now builds some intelligence in your application to route queries to the best place rather than just one hard-coded endpoint in terms of your large language models. So this is really good for, actually one of the options is being able to optimize based on cost. So you can pick that you want some of those easier questions to go to the nano model instead of sending it to the big LLM that was more expensive per million tokens. So the model router is definitely worth looking at. I'm going to get my hands on it now that it's been made public. And then also fine-tuning. So fine-tuning is about if you're training an LLM on your own data set and you want it to get better, you might want to run through some fine-tuning. If you remember when we looked at that table that had all the prices on it, fine-tuning has an hourly rate. So we want that to be as fast as possible so it can be done and we can close that resource and not have any cost anymore. But the great people in this product actually turned around and developed a developer tier that gives you 50% discount and a higher quota and does not have an hourly rate for fine-tuning on the developer tier, which is great because the developer tier where you're playing around and you're experimenting is usually where you're going to generate more cost because you haven't optimized it yet. So to be able to do fine-tuning without that hourly cost in the developer tier is really useful. So I encourage you to get your AI engineers to go and take a look at that one. The next piece of technology that you can add that has some benefits in terms of cost optimization for your workload is the Gen AI gateway. So you may or may not be familiar with the Azure API gateway. It has some generative AI capabilities in it. One of those is the Azure OpenAI token metric policy. So the token metric policy will emit metric data into log analytics that can help you separate out the traffic of where things are coming from. So if you have more than one large language model inside your application, or if you've got one model, you can actually split it out. So you can say that requests from this place go here, or if you want to do cross-charging, you might have multiple front-end systems that are going to the same AI backend. If you want to be able to split the charging across those different systems, you can actually get it to identify where that request is coming in from to the LLM and emit that metric data back so that you can then split up the cost across the 3 different services that are using that same AI model. The next one is a token limit policy. So the token limit policy, really good if you think of in terms of denial of service attacks, where you might want to slow down or block requests coming into your AI service if it's being flooded. So if you've got a potential attack, you've got something going weird, and you're getting absolutely hammered with inbound requests into your LLM, you're going to start paying for that per million tokens. Okay, so you can use the token limit policy to define the behavior of what happens when that system gets a little busy, whether or not you slow down and throttle things and just protect that AI service from being too busy. The next one is the semantic caching policy. So semantic caching policy is a little bit similar to token caching, but it's more about like caching the vibes, right? The caching some of the information that's not necessarily all of the tokenization of the input that's come in. But semantic caching, again, the chatbot is now going to be able to go back into the cache and remember that the conversation that it's having with the customer is generally positive, or this customer is really unhappy, and it's going to change its behavior to handle the vibes of the conversation. Now that we've talked about some of those tips in general for optimizing your AI workloads, pre-built models in Microsoft Foundry may be useful without you having to go and train your own. Spend your time doing that on your own models. Make sure you're using the right series of models. Optimize the token usage. So when people are developing applications, are they combining token requests? Are they making sure that they're not sending the entire conversation every time with the input? They're only sending the last couple of questions. And so how they actually handle those inputs from an AI perspective can impact your costs, and right-size your other application components. And consider model router and token routing, the two that have just been announced as well. Next step is rate optimization. So now that we've talked about how we can sort of optimize how the stuff comes into the system and what costs are generated, what can we do in terms of the prices that we're paying? So with rate optimization, you want to look at something called provision throughput units. And provision throughput units are also good because they actually come with a service level agreement for guaranteed throughput and a maximum latency. So if you have mission critical, high performing applications that you need to guarantee performance on, by enrolling in PTUs, you actually get a guarantee on the throughput and the latency of the responses through to those models. They are really good when you have defined predictable requirements. So you've got a good idea of how many tokens you are processing. You might not necessarily start out with them, or you may do a proof of concept for your application first before you have that data to go and do commit to provision throughput units. But the interesting thing is that they used to be locked in for a month. Now you can do them hourly or uncommitted. So there's less risk there if you want to lock in a certain number of provision throughput units, which is, this is the amount of tokens I'm going to commit to my application using in an hour. If you get that wrong, it's not too hard to go and change it the next hour. You haven't locked that in for an entire month. And the way that you can measure and maintain how your application is performing versus what you signed up for in terms of a PTUs is a provision managed utilization metric. So again, this is a metric that the system will generate so that you can compare the actual usage for your application compared to what you signed up for in terms of PTUs. PTUs are a bit of fun to get started with. Again, a bunch of learning links for you to go and learn more on how to deploy them. We have recently, like within the last couple of months, added PTUs to Microsoft Foundry in the experience when you go and deploy a model. So when you go and do your model deployments, it will actually come up with a box that recommends PTUs and gives you the ability to go and add that in on time of deployment, or you can do it after the fact when your model's already up and running. So that's a kind of a good section on cost analysis, estimation, and there is a link there to the new information about model router in Microsoft Foundry. That documentation is still changing over, so just be aware that if you're looking for stuff about Foundry, and even when I was looking for model router, some of our docs will have a warning label on them to say, this relates to Microsoft Foundry Classic. Click here for the new documentation. As I said, with only just public releasing it a couple of days ago, those docs will flick over until you've got all of the new stuff. But if you are reading documentation, just have a look. It's usually very clearly labelled whether it's referring to the old Foundry application or the new one. Next, let's talk about preventing cost overruns. So I talked a little bit about how you can throttle down and protect all those incoming token inputs if you're being overwhelmed a little bit. But honestly, there are not a lot of cost controls for AI services. I would hope that if you are running virtual machines in your environment, you are using an Azure policy to restrict VM sizes. You can go and do that to block anybody in your organization from deploying an E-series virtual machine that can send you somewhere in the vicinity of $12,000 to $20,000 a month. If you don't want people doing that in your organization, there is an Azure policy where you can set to allow which VM SKU sizes can be deployed, and definitely don't put those ones on. There is no such policy like that for our AI services, unfortunately. So I kind of came up with a bit of a workaround. What you can do instead is go into cost management and set a budget, create an alert based on thresholds of when that budget is hit or it's close to its limit, and then go and call a workbook. Okay, so I don't know how many of you are using workbooks for automation inside your Azure environment. You can use workbooks and automation on budget alert thresholds to go and do some stuff when budget alerts are hit. By default, natively, our budget alerting system will not do anything with resources. It requires a human to go that next step to do something, because we do not want to start automatically shutting down things based on budget alerts. We want a human to review it and make that happen. But if you're confident that these workloads specifically you can shut down, then you could build in some automation with Azure workbooks. The interesting thing though is that once you've deployed these models, you can't stop them like you can stop a virtual machine. They will sit there listening for inputs to go and process tokens for as long as they are a resource. So if you wanted to stop them from being responsive, you would have to delete them, which is not ideal. Unless you get crafty like I did and actually relied on the network settings. So those model deployments will have two settings for network access. One of them is allow anything to talk to me, or only allow things that are in the allowed list to talk to me. So I've actually got a PowerShell script that you can use to say, if this model deployment is listening for requests from anybody, when this automation kicks in, when I hit that budget alert threshold, flip that to only accept requests from allowed IP addresses, don't put anything in the allow list. Now it's not going to be able to handle any requests, and I've in essence paused my LLM until I can figure out why we've got a cost spike. Okay? If I'm using an LLM model that I have got structured to only listen from particular endpoints, so if I've locked that down because I've got that as a back-end service, it's not public facing, I've gone in and I've defined the IP address of the different components of my application architecture that are talking to this LLM, I have another PowerShell script where you can put in those allowed IP addresses into the PowerShell script, and the PowerShell command in the workbook will go and remove them from the allowed list. Nothing in the allowed list, service can't let anything talk to it. So it's fun to get a little bit exploratory with what you can do with these services when Microsoft says we're not going to give you a way to push your LLMs. Yeah, look at that. Look at things like network access. So that's a bit of fun with budget automation. Again, some good learn more links here in terms of the token metric policy, the token limit policy, and the semantic caching policy that I mentioned that is available with Azure API Gateway. Okay, last but not least, managing cost with FinOps. Raise your hands if you know what FinOps is. Very cool. Raise your hands if you're actively using it in your organization. Okay, a few less hands, cool. Raise your hands if you've got a FinOps certification. Wow, couple of friends. Well worth doing, well worth doing. So, for the people in the room that haven't heard of it before, the official description is FinOps is an evolving cloud financial management discipline and cultural practice that enables organizations to get maximum business value by helping engineering, finance, technology, and business teams to collaborate on data-driven spending decisions. That is a mouthful. In essence, what it means is it is a framework that combines people, processes, and tools to make sure that everybody in the organization that has an interest or a responsibility for cost management can work together. And so that we can ensure that the money that our organization is spending on technology and on cloud is optimized and it is giving us a return on our investment. It's actually enabling the business and it's making the business money. That ultimately is what we wish for any cloud spend. But the FinOps organization have worked together across different vendors to put together the FinOps framework. Now, Microsoft is on the Technical Advisory Council on the FinOps Foundation for a number of projects, including the FinOps framework. And I'm going to step you through a few principles, and I'm hoping that we might have a few more FinOps converts walk out of the door when they see some of the awesome things that it has. First thing is principles. These are the guiding foundational things that underpin everything that we do, including the fact that teams need to collaborate. Decisions are driven by the business value of the cloud. So right back to the conversation about business requirements drive architecture decisions. Decisions on what we're spending our money on is driven by, are we going to get the value out of it for our business? We need to make sure everyone is taking ownership for their cloud usage, because we don't want to be in this tussle where we've got the finance team complaining that people are spending too much, and the application development team are going, but I just picked this thing because it was, you know, it was a very large model, or it was super responsive, or whatever it is, or ignoring the fact that they might need to do some work if costs are blowing out unexpectedly. FinOps data should be accessible and timely, so that's making sure that we're getting a good quality of regular data about the costs of our things from our cloud vendors. Having a centralized team to drive the discipline around these different principles, to become the experts in it and to impart their knowledge into the rest of the team, and also taking advantage of the variable cost model of the cloud. So within the framework, we take those principles across to our domains and our capabilities. The domains are the blue headings. They're the ones that we are trying to achieve ultimately. They're our goal. We want to understand our cloud usage and cost. We want to quantify the business value, optimize the usage and cost, and manage the practice of being a financial discipline in there as well. And then we break down underneath those domains into these various capabilities. Choose your own adventure, right? If you have been in IT and read a book called The Phoenix Project, there is this analogy about a manufacturing plant floor and taking a look at the machinery and finding out where the bottleneck is, that by fixing that, we unlock the most benefit. So it's not spending time on the small things, it's finding out what's the most important thing to start with. And that's kind of what you can do with the FinOps framework, is you can sort of pick and choose your own adventure through what do you need to start with. And then we have some phases and some maturity. So FinOps isn't just for Christmas. You're going to start at the crawl phase where you're trying to get some of the basics together. Often for organization, that starts with things like data ingestion and reporting and analytics. So do we have good, clean data that we can access in a timely manner, or we can get it to the right people? That's normally the first thing before we start making more decisions off that data, more automation, and we start optimizing things and moving into things like forecast. But this inform, optimize, operate phase, you will go round and round and round with different capabilities as you make these individual things better, as you improve your data ingestion, as you improve your reporting and analytics, as you improve your workload optimization. So we're constantly going to come back and around and do these things. So there's some great information from the FinOps Foundation on how to really sort of formalize, but get your people, your processes and your tools working together across your cloud spend, so you avoid some of those, it's a finance problem, it's an engineering problem type conversations. In addition to that, the foundation has worked on something called Focus, which is the FinOps cost and usage specification. I don't know if anybody in here has ever tried to compare an AWS bill to an Azure bill or a GCP bill. I can tell by the giggles that a few of you have got flashbacks about having to do that. Focus is the foundation's answer towards normalizing what the cloud vendors call things, so that when you compare bills from one vendor to another, it's a little bit easier. Unfortunately, the data exports for Microsoft Cost Management you can get out of Azure are able to be exported in the Focus format. So we do support it, and we recently updated to version 1.2 of Focus, which came out as well. So we will continue to be able to provide you a way to export your data in Focus format to make it easier to compare with other cloud vendors. That sounds a little bit weird, that I want to make it easier for you to do that, but I'll tell you one reason why that's really good. It's super good because if someone who is an AWS customer comes up with a great way to do a report or an automation or something in the FinOps vein, like it could be the best cost data report that you've ever seen, if they've built that using the Focus standard, you should be able to pick that up and plug in your Azure data and use it. So the more that our cloud vendors can standardize on things like this, the more that the community can grow and make better tools, and we can share that information with each other, the more that organizations can do cloud cost management across their organization, no matter which cloud vendor they're using. So that's all good for the industry. In addition to that, the FinOps Foundation has brought out a FinOps for AI certification. So I'm going to encourage you to go and do the FinOps training. There's a great book from, I think it's O'Reilly that you can read. The exam to sit to get the first level of being a FinOps certified person is fairly simple. There is a lot of business structure in it. So if you're familiar with how businesses operate and how you're doing cost management, it's not deeply technical. It's more about processes and culture. But they have brought out a specific training around how you apply FinOps principles to AI. Now, at the moment, level 1 is out. I think level 2 might have just come out. They're doing a progressive rollout of the training material of the certification into next year, and finally they will release an exam so that you can get a FinOps certification for AI. But if you sign up and want to do the training package, you are entitled for a period of 2 years to access the training content and pick a time to go and do the exam when it's available as well. And finally, I just want to leave with a note on sustainability. So it's all very good for us to sit in this room and talk about how much will it cost, but there are a lot of people that are asking about what is the environmental cost of AI. And we have great resources at Microsoft about our sustainability initiatives, about things like closed loop water recycling for our cooling, but you can actually go into the Azure Carbon Optimization dashboard inside the Azure portal and see the carbon footprint that your workloads are generating, including your AI workloads. So you can have that conversation if somebody wants to know how much carbon emissions are we getting from all of this AI stuff. It's now not a conversation of trying to convince somebody that because Microsoft said they were using closed loop water recycling, it must be okay. Now you can actually pull up the data. Not only can you pull up the data, but if you put any initiatives in place to improve that application, you can see if it's making a difference to your carbon emissions as well. So you can go and make that somebody's mission. Again, bunch of links if you would like to learn more about the FinOps Foundation. We have some Microsoft specific guidance on adopting FinOps with Azure. If you're going to do one thing on this, I would recommend the FinOps review, the FinOps assessment. So that's a little interactive survey that we've built where you can actually step through. It'll ask you a bunch of questions and it will benchmark where you are in the maturity of your FinOps practice and what you should go and do next. So again, also a really good benchmarking tool to do that once, make some improvements, and then redo the assessment, but it'll give you a really good place to start. And then I've also put up some training modules. So on Microsoft Learn, we've got Introduction to Cost Management for AI Workloads and Establishing Cost Management Practices for AI. I'm currently writing a third module to add on to that, which will also have PTUs and some other things in it, so watch the space. It'll be linked to as a related resource. And then we've also got Manage the Cost Efficiency of AI Agents on Azure. Now, I didn't say the word agents once. You might have heard the word agents in the conference this week, but that is kind of the next thing to take a look at, and we've got some good learning material, a learning path on Microsoft Learn specifically around AI agents and their cost management as well. And that concludes my presentation. I would really value your feedback if you could pull up that QR code. Like, I've seen you with your phones, get them out, take the thing. That will give you access to all of the sessions that you added to your scheduler to go and fill in your feedback. I'm going to tell you this session may or may not have happened. If you want more sessions like this, please tell me in the feedback, and I will also personally read every single feedback comment that's submitted on the session so I know how I can improve it for next time. Thank you so much for your time.